Now it's about the method of statistical quality control. There are two methods, mainly process control and product control. Here we go through only process control. So here control chart, we will understand about it. Let's go through it. Under process control, the most important statistical tool is control chart, which is helpful in controlling the quality of the product while it is being manufactured. Its purpose is to control charts are often called switchboard of statistical quality control techniques, from which the whole picture is known at a glance. It has various advantages. Now we go through the form of control chart. Control chart is characterized by three horizontal parallel lines on which the relevant statistics are plotted. First is central line, then upper control limit, then lower control limit. Central line, the middle line of control chart, is called central line, which represents the average value of the plotted statistics for a number of samples in a perfect and ideal manufacturing process. Central line, the middle line of control chart, is called central line, which represents the average value of the plotted statistic. It's a perfect and ideal manufacturing process. Then comes upper control limit. The upper line is the control chart. In control chart is called upper control limit. It can be said as mu plus 3 into standard deviation. Then third, lower control limit. The lower line in the control chart is called lower control limit. Lower control limit is located at 3 standard deviation. 3 standard deviation, or it can be written as mu minus 3 into standard deviation. This is the form of control chart. Mu plus 3 standard deviation, upper control limit or UCL. Mu is central line CL, and mu minus 3 is lower limit LCL. So normal distribution in control chart is given here. Warning limits, other upper control limit, inner upper control, central line, so not so important, I think so. And here comes types of control chart. There are two types of control chart. Control charts for variables, for attributes. First of all, we go through variables. There in this chart we can see three types in variable: mean chart, standard deviation chart, range chart. Here comes for attributes P chart, C chart, and NP chart. Let's start with mean control chart. This chart is used to know whether the sample means are within the limits or not. This chart reveals whether the variation is due to assignable cause or random cause. Random cause. Then we can go through the steps. So this is step to find sample mean. We have to compute the mean of each sample. We all know the formula of mean as sigma x by n, that is x1, x2, x3 up to n by n. Here x bar is sample, sigma x is size of all the values of a sample, n size of each sample. Now to find central line, we need to calculate mean of the means, that is x double bar, as shown. Sigma x by k, k here is number of samples. So this is the formula. Just if we can understand the formula, we can easily put the values in it our answer can be easily available, can be easily computed. Now to find the control limit, upper control limit, lower control limit. If it's given population standard deviation, this we have to go through this formula. UCL, mean of mean plus 3 standard deviation population divided by root of n. And for lower limit, no need of understanding, just put the minus. Now comes population standard deviation based on R. If standard deviation population is not given, then we have to determine range as we know, larger sample minus smaller sample, or its value will be given R bar by D2, and here R standard deviation. If standard deviation is given, then standard deviation bar by C2. C2 D2 value will be given in the question. Now if C2 D2 value is not given, and if the value of E2 is given, then we have to put this formula: mean of mean plus A2 R bar, mean of mean minus A2 R bar. Now its A2 value also not given and A1 value is given, then this will be the formula: mean of mean plus A1 standard deviation bar and mean of mean minus A1 standard deviation bar. Now then the fourth step will be plotting of sample point on x-axis and y-axis. Then we have to interpret it that it's out of control or under control. Let's go through question 1. Here table is given: 25 working days, 20 months each. Population standard deviation is mentioned here as 35 units, and it's saying draw a control chart for the mean. Okay, so these are the points. By this we can calculate this. Mean of mean can be calculated to this value. Then I have solved it by my own. So first of all, we need to write all the given parts. K, that is 20 months as given in the question, number of sample in 25 working days, size of each sample, standard deviation population as 35 units, population standard deviation. Then we need to let's write the formula of central line and putting the values. Here we get, by putting these values in formula, divided by 20 is here K, mean 1, mean 2, mean 3 divided by K. It's the mean given divided by 20. So central line amount came. Now next, upper control limit formula: mean of mean plus 3 standard population by 210. Just putting the values, we get 231. And lower control limit, mean of mean minus 3 standard population root n. Putting the values, we got 189. So the control chart. So here we have drawn the graph. We have plotted the values here, the table values, these values to be plotted in y-axis, that is measurement of mean, and in x-axis number of samples, 1 2 3 4. Here it's the upper limit 231, central line 210, and lower line 189, and the values that is 210 to 5 to 10 doesn't crosses the upper line. We can see through this graph. It's going on, doesn't touches upper limit nor it crosses the upper limit. So as it doesn't crosses upper limit, it's under control. If it crosses the upper limit, then it will be considered as under control. If it crosses, then it will be out of control. As it doesn't crosses, it's under control. Now we can go through range chart or R chart, the second formula to calculate control chart for variables. The range is the difference between maximum and minimum value in the sample. As we know, if we need to calculate R chart, and simply R, we know range equal maximum value minus smaller value, where R equal range and largest value and smallest value. Find central line R bar equal R1 plus R2 R3 divided by K, that is sigma R by K. To find control limits based on population standard deviation, if it's given D2 and D3, then UCL R bar plus 3 D3 into standard deviation population, or if standard deviation population doesn't given, then R bar divided by D2. Same in LCL, R bar minus 3 D3 into standard deviation population, or R bar minus 3 D3 into R bar D2. Then if the value of D2 and D1, capital D2 and D1 is given, then its formula will be upper control limit D2 into upper limits will be D2 into standard deviation population, and for lower D1 into standard deviation population. And if the value of D4 and D3 is given, not the value of standard deviation population or R bar isn't given, the value of standard deviation population D3, D2 and capital D2, D1, then there will be value of D4 and D3. Then we have to calculate by UCL equal D4 R bar, LCL equal D3 R bar. And same like main chart, we have to plot it in the graph, then we will interpret like mean chart. It will be the quality control factors. N is 2, 3, 4, likewise 20. Value of D2, D3, D1, D2, D3 and D4. Let's do its one question. Here size is given as 5, 20 samples as K equal 20, size is given, so N equal 5. Sum of 20 sample ranges is 410 inch. The sigma R is given as 410. 410 by 20 for 20.5, that will be our central line. Then for standard deviation population, we know R bar by D2. So here R bar we got 20.5 divided by D2. Values are given, small d2, d3. By putting the value of d2, we get 8.81. Then upper control limit R bar plus 3 into d3 into standard deviation population, and elsewhere R bar minus 3 d3 into standard deviation population. By putting the values, we get like this: 43.34, 43.34 upper limit, and by calculating LCL we get 0. It's actually the value is in minus, so we can consider it as 0. And central line we get 20.5. We got the all three values. By plotting it on the graph, we get sample number, x-axis, y-axis, 20, 20, 30, 40. Let's consider it as like that. Then 40 UCL for 3.34 we considered as 40, and lower limit as 0, upper limit central line 20.5 here considered as 20. Now let's go through standard deviation control chart, the third method of control chart for variables. Standard deviation same, we need to calculate standard deviation 1 to 3, standard deviation bar equals standard deviation 1 plus 2 plus 3, that is sigma standard deviation divided by k. And to find control limit, for upper control limit, if population standard deviation is given, then UCL equal standard deviation plus 3 standard deviation population divided by 2 root n. Standard deviation population here will be standard deviation bar divided by C2. And for LCL, standard deviation bar minus 3 standard deviation population by root 2n. And if the value of standard deviation population is not given, then here we will put B4 and B3 as upper and lower. B4 into standard deviation bar, LCL as standard deviation bar into B3. Let's go through its question. Here it's given n equal 8. Sum of sample 15, that is K15. Standard deviation 60. Standard deviation population as 2.4. So by putting the values, we get like this. So central line will be standard deviation bar is sigma standard deviation by k 60 by k15 is 4. UCL formula will be standard deviation bar plus 3 standard deviation population divided by 2 root n plus and minus. Then our formula, by putting the values, we get like this. And just to plot it in the graph. 2.2 LCL, central line 4, upper control limit 5.8, y-axis, x-axis, now let's go to control second method. It is control chart for attribute. The qualitative characteristic of the manufactured product cannot be expressed numerically, but simply we consider its presence and absence. Here we consider the number of defects per item. Now the control chart for each situation are called control chart for attributes. Here also three types: P chart, NP chart and C chart. P chart, proportion or fraction of defective, is based on binomial distribution, and P equal defective units in sample divided by size of sample. Central line P equal P bar equals P1, P2, P3, that is sigma P by K. Central line total number of defectives defected by total number of units n into K. For control limit, UCL equals P bar plus 3 standard deviation नहीं आएगा इधर, it will be under root P bar q bar divided by n. And if I will say just plus minus p bar minus 3 under root p bar q bar by n. And we have studied in probability q bar equal 1 minus p bar, same to be applied here. So it's a question. Here given sample number from 1 to 20. The total number of units inspected in all sample will be 20. It is 20 working days into 100 items each. So into 100, 20 into 100 will be down. And number of defective units are given, just plus all the values. We get total number of defective units in all samples. And by putting the formula, central line for, we need to calculate p bar, which is 200, as we have studied here. Value will be 200 by 2000, it is 0.10. So q bar 1 minus p bar, value is given here. So control line or the central limit will be 0.10, and UCL p bar plus 3 under root p bar q bar by n. Just putting the values here, we get upper limit as 0.19 and for lower limit 0.01. By plotting the graph, we get like this. So as the graph crosses, or the number plotted crosses the upper control limit, it will be interpreted as out of control. The second formula will be NP chart. Its central line will be calculated like NP equal total number of defective sigma d by k, total number of defective divided by number of sample. UCL will be NP bar plus 3 into root n p bar q bar. LCL n p bar minus 3 under root n into p bar q bar. And third and last method of control chart for attributes will be C chart. Till central line for C bar, we need to calculate total number of defects in all the observed item divided by number of items. Control limit can be based on Poisson distribution, studied in probability. So upper control limit equal C bar plus 3 under root C bar, and for lower limit C bar minus 3 under root C bar. Is the question. C bar values are given, just add it on. Number of units here given 15 pieces, so divided by 15. Lower limit, central line, we get 9. By calculating the other two values, we can plot the value as upper control line, central line, and the lower control limit. It's a graph, and we can say interpret it as it shows out of control as it crosses upper control limit. Thank you.